All right, guys, welcome back. This is our second video for distance learning. Today we are talking about trig. This is something that I mentioned in the last lesson when we covered Pythagorean theorem. So trigonometric ratios deal with right triangles, just like we saw with Pythagorean theorem. Just a reminder, ratio is another way of saying fraction, which is a number divided by a number. Okay, so when we talk about trig ratios, we're going to be looking at the ratios between the sides in those triangles. Okay, so the essential question for this lesson is really simple. What are, and I'm going to abbreviate this, what are the trig ratios? Okay, so eventually we are going to be using what we learned today to solve for missing parts of triangles, but today we're just talking about the names of the ratios and how we represent them. Okay, before we jump into that, some really important vocabulary words. I would take a second, if I were you, and pause the video, jot all of these words down, and as I am labeling this triangle, maybe write a short definition in your notes in your own words. Okay, so we mentioned this word last week, hypotenuse. That is always the longest side in the triangle. Okay, so for what we are doing today, we're going to be using letters to label our triangle and show these different parts. The hypotenuse, we're just going to use an H. Okay, so when you are doing these problems, you always label the longest side, which is across from the right angle, as H. Okay, the adjacent side, we're going to get to that in just a second, and the opposite side. Before I explain these three words, I'm going to skip down to reference angle. So the reference angle is our point of reference for how we label things in the triangle. Okay, so when I say that, we are either going to be using the lower acute angle or the one at the top, depending on how the triangle is rotated or how it appears. Okay, so just for the point of what we're doing right now, we are going to say that D, angle D at the bottom, is our reference angle. And when we denote the reference angle, we are going to use this little half circle mark. Okay, all right, so that's our reference angle. And if you look, the word above reference angle is theta, and that word is a Greek word. It's a letter in the Greek alphabet that is used to show where the reference angle is located in the triangle. Okay, so that little symbol right there is either going to be down here at D or up at the top at E. Okay, but it's really important to remember you only have one reference angle. Okay, you never put the reference angle on the right angle. It's always the acute ones in the corners. Okay, so like I said, we use that Greek letter theta to show where the reference angle is located. Okay, all right, so hopping back to adjacent and opposite, in the same way that we used H to show hypotenuse, we are going to use A and O to show adjacent and opposite. Okay, so where these two things are located depends on where the reference angle is. Okay, so since we chose D as the reference angle, our opposite side is going to be the side that is across from the reference angle. Okay, so if you look in the triangle, the hypotenuse is obviously right here next to D, and then this side, DF, is also right next to angle D. It creates that angle with the hypotenuse. Okay, so that means the side opposite, okay, not touching that angle, is EF. And again, we're going to use an O to show the opposite side. Okay, the adjacent side is the side that's remaining at the bottom. That side always creates the reference angle with the hypotenuse. If you trace your pencil along that angle, it will always be created by A and H, with the opposite side being across from that angle. Okay, so it's really important here that you understand, number one, what the reference angle represents, and then how we label the triangle based off that reference angle. Okay, so let's say that instead of choosing angle D for the reference angle, we decided to put it up here at angle E. That would mean that the O and the A would flip-flop. The opposite side would now be down here on DF, and the adjacent side would be at EF, okay? So the reason that we learn these things is because these ratios between these sides are the trigonometric ratios, okay? So before we jump into that, again, I would pause the video, make sure you are very clear on what the definitions of those words are. We are going to go ahead and practice labeling our triangle based off a given reference angle, okay? Okay, so for these three examples, it gives us the location of the reference angle. So we will mark that using that little tick mark and theta, and then we will label the opposite, adjacent, and hypotenuse sides, okay? So angle J is my reference angle in the first triangle, so I'm going to put my little mark and draw my theta. I'm a pro at drawing thetas. If you feel like you're not great at doing this, just draw a 0 and put a line at the top, okay? That's perfectly fine. Okay, so now I need to label O, A, and H. Okay, so remember the hypotenuse is H, the adjacent side is A, the opposite side is O. So I can clearly see that JL is the longest side in that triangle. It's across from the right angle. So this will be my hypotenuse. Never changes. The side opposite of J, if I take my pencil and run it straight across, I can see is KL. Okay, almost drew an A. And then, so we've done O and H. My adjacent side is what's remaining, the side that creates my reference angle with the hypotenuse. Okay, and this seems a little weird at first. We don't have a context for understanding it. But once you've practiced it several times, it becomes second nature, okay? All right, so moving on. Example 2, angle Q is the reference angle. So I'm going to draw my mark, show my theta. Again, we are labeling the opposite, adjacent, hypotenuse. My longest side is PQ. It's across from the right angle. My adjacent side is not PR, okay, because that side is not creating the angle with the hypotenuse. This is adjacent, and then the opposite side across from my reference angle is PR, okay? So when you're doing these problems, you always start this way. You mark your angle. Sometimes it's given to you what the reference angle is. Sometimes it's marked. You just have to look at your problem and what information you're given. But you always label those 3 letters at the very beginning, okay? All right, so example 3, T is my reference angle. My hypotenuse is TU. My opposite side across from my reference angle is UV. And then my adjacent side is down here at the bottom, that is TV, okay? So at this point, we are gonna be adding a new layer to this lesson. So if you feel like you still have not mastered this, I would go back to the top, rewatch the video, make sure your notes are complete, and then move on to the next section, okay? All right, so this is the most important thing that I'm going to be talking about in this video. This is something that you will see probably in math for the rest of high school. So if you don't have a good understanding of it, it's going to be a struggle, okay? All right, so sine is the name of the first trig ratio, okay? So guys, when we define each of these ratios, we are going to be using those 3 letters O, A, and H, okay? So this is it's going to look kind of weird, like a different language at first, but as we practice and as we do different problems, you'll start to understand what it all means, okay? But these are the definitions. So the sine of an angle, we always use that theta symbol to represent a reference angle. The sine of theta is equal to the ratio or the fraction between the opposite side and the hypotenuse side. Okay, so let's say, for example, in a triangle, we're given the hypotenuse is 12 and the opposite side across from the reference angle is 6. The ratio would be 6 over 12. Okay, so it might be helpful here. Let's draw a little triangle. Okay, so let's say here's our reference angle. There's our theta. My opposite side is here. My hypotenuse is here. and my adjacent side is down here. The sine of this reference angle is going to be the ratio between those two sides. And obviously we'll be given numbers in the examples that we'll be working on. Okay? All right, the cosine, and I'm abbreviating these, is always the first three letters. The cosine of my reference angle is the adjacent side over the hypotenuse. Okay? So if I'm using the same triangle that I used for sine, I have my theta down here, my adjacent side, my hypotenuse side, and my opposite side, I'm going to be using the length for the adjacent over the hypotenuse side. Okay?